A six-sided die, you throw it until you observe a 5. Find the probability that you throw the die at least 4 times and no more than 15 times. So let's start with that. Let AI be the event that you get a 5 for the first time, on roll I. Then we can formally describe this event up here as the union from I equals 4 to 15 of AI. Now call this event, well, let's not give it a name. We're looking at the probability of this union. Okay, well, what do we do here? These events are disjoint because if you get an I on the 4th roll for the first time, then your first I can't have occurred on the 8th roll. And if you get an I for the first time on the 12th roll, then you won't have gotten an I for the first time on the 8th roll. So they're disjoint. What does that mean? That means we can sum them. So sum from I equals 4 to 15 of P of AI. Well, now how do I compute this guy up here, P of AI? Well, that, you notice, you have to get I minus 1, not 5s, and then a 5. So if we think of this as like a tree, this is 5, this is not 5. Okay, if we get here, we stop. If we get here, we go on again. 5, not 5. And go on one more time, and so on. 5, not. All right. So for the first I to occur on the for the first 5 to occur on the ith roll, we have to get I minus 1, not 5. So I minus 1, not 5s. And then a 5. Then a 5. Well, the rolls are independent, right? So if the rolls are independent, then P of AI is equal to the probability of, let's say, BI, let that be, get an 5 on roll I. Okay, so the probability of AI, actually we should call this BJ. So the probability of AI is the probability of B, let's see, the intersection from J equals 1 to I minus 1 of BJ. All that intersected with BI complement. So all we're saying here is the probability of AI is I did not get a 5 on rolls 1 through I minus 1, and I did on roll I. But these events are all independent, so then all this is, well, I can multiply all these probabilities together, right? So the probability of BJ, the probability of BJ is a 6th. Right. Oh, I made a mistake up here. This should be the complement because I didn't get a 5 on roll J, and then I did on roll I. Okay, so probability of BJ is 1/6. The probability of BJ complement is 5/6. So we have I minus 1, 5/6, and 1, 1/6. So this is 5/6 to the I minus 1 times 1/6. All right, so now I need to sum all of this up. So how do we do that? Well, this should be looking pretty familiar to you by now, if you remember your geometric series from calculus. All right, so there's going to be a little bit of manipulation here, and I want to make sure that it's clear what I'm doing. So I'm going to write out the entire sum down here. So it's the sum from I equals 4 to 15 of 5 over 6 to the I times to the I minus 1, times 1 over 6. So here we have, everything has at least 3 5/6 in it, and it has 1 1/6. So I can take those out, and then I can rewrite my sum. So first I'm going to take the 1/6 out. So that's 1 over 6 times the sum from I equals 4 to 15 of 5 over 6 to the I minus 1. Well, now I can just kind of shift my index down by 1, because if I was 4, and then I just have a 3 up here, and when I is 15, I have a 14 over here. So I'm going to shift my index down by 1. So I have 1/6. Now it's the sum. Let's call it k. So right where k is equal to 3 to 14. So k is just equal to I minus 1. And then this is 5 over 6 to the k. And now we can reindex one more time, just changing our k, because we're going to pull out. We notice that since k starts at 3, every one of these terms has at least 5/6 cubed. So now we can just write 1/6 times 5/6 cubed times the sum of k equals 0 to 11 times 5/6 to the k. And I could have just given this a new variable name again if I wanted to, but I didn't have to. K, just a label. Could be squashed cockroach. You could call it whatever we want. So I pulled out this 5/6 cubed because it starts at 3. Now we start at 0, but this guy over here, this is the partial sum of a geometric series. And the general formula for summing up that geometric series, well, let's say it starts at 1, because 5/6 is 0 is 1. Then we have 5/6, 5/6 cubed, and so on. That's a geometric series. So let's take this guy over here. Now we have a 6th times 5/6 cubed times this sum of a geometric series. And you can look this up on Wikipedia if you're not sure and you want to refresh yourself on the definition, but we're summing from 0 to 11, so that is 1 minus 5/6 to the 12th divided by 1 minus 5/6, 1 minus 5 over 6, which is equal to 1/6. So this gives us 1/6, 5 over 6 cubed, and then we have 1 minus 5 over 6 to the 12th divided by 1 over 6. And then this is going to come out and kill this term here. So what do we have? We have that this, remember this is going to cancel this guy out, right? So this, let's see, this is dead. This is dead. So we have 5 over 6 cubed, and then 1 minus 5 over 6. 5 divided by 6 to the 12th. So what are we left with? We can just multiply this through if we want. And that is the simplified form. Kind of a pain, but you got to remember your geometric series, and then you'll get to geometric random variables, and you'll see how this all ties together.